So, hello everyone. Can the people at the back hear me still? I'll try to be loud enough. So hi everyone. This is the exercise on the introduction to Activity Browser, software used to conduct lifecycle assessments. And my name is Alexandra Kim. And with me here is Sandra Lawrence and Jing Hua. If you have any questions, feel free to ask any one of us. Feel free to also interrupt me in the middle. Yeah, let's get started. So the learning goals for today are to understand what is Activity Browser and how can we use it for lifecycle assessments. We also would be looking at the structure of the projects in Activity Browser, at the databases there, at activities exchanges, and how to explore them. We will learn how to import lifecycle inventory databases, such as Biosphere, Technosphere, Ecoinvent, foreground databases, and so on. We will also look at how to get information about activities and exchanges in the Activity Browser and how to look at lifecycle impact assessment methods. And finally, we will compute lifecycle impact assessment scores, and we will look at a simple case study with the Activity Browser. Note that we will conduct a case study on the We will start today, but for your graded exercise, you will have to build on that exercise, so please follow it. Yes, so if we are talking about Activity Browser and lifecycle assessment computations, then we need to keep in mind three maybe important packages, things, or notions. These are Python, Brightway, and Activity Browser itself. Python is basically a high-level general purpose programming language used nowadays in many applications, ranging from web to data science to scientific computing and in research projects as well. Python, there are many packages that have been written in Python, many libraries, they have different versions and they have all dedicated functionality. Some of them are used for plotting, for example, others for numerical computations, others for data science, and so on. One of such packages or libraries is Brightway. This is basically a Python library for lifecycle assessment computations. And the Activity Browser is a graphical user interface built on top of Brightway. So both of these tools, they provide functionality to run lifecycle assessment computations, such as, for example, working with lifecycle inventories, creating new ones, exploring existing ones, then computing lifecycle impact assessment scores, or conducting contribution analysis, regionalizing data sets, doing sensitivity analysis, and so on. So both of them allow such kind of analysis. But Brightway is a Python library, whereas Activity Browser is the graphical user interface. That means that Brightway requires good knowledge of Python, whereas Activity Browser doesn't require any knowledge of Python. As a consequence, Brightway is a little bit harder to use, but it is also a bit more flexible. Whereas Activity Browser is easier to use, but it is also less flexible as we are restricted by the functionality that the developers of Activity Browser chose to implement in their graphical user interface. We will be here using Activity Browser. And it's important to note that for you to get started, that both Brightway and Activity Browser are under active development at the moment. So it means that they have multiple stable or less stable versions. And they also depend on other libraries that also have multiple versions. So to kind of be able to work with all of those libraries without any dependency conflicts, what people do is they use virtual environments. In this case, the specific tool we use is Conda environments. Basically, a virtual environment is like a folder that contains source code of other libraries of their specific versions. And when you activate a virtual environment, then you can start using those specific versions of specific libraries. So you shouldn't have any conflicts in your or any problems in running your code if you consistently use the same virtual environment for the same software. So they are basically needed to ensure compatibility between different versions of Python and Python packages, and they contribute to reproducibility of results. In this course, we will use Activity Browser and Conda environments. And there are online tutorials on YouTube that you can take a look at, but we'll basically go through the same material today. We have already on these computers pre-installed the Conda and Activity Browser. So the instructions on how you can set it up yourself are given here. If you follow the link, then you will see a PDF file. Please don't do it at the moment because this exercise is really about getting to know Activity Browser. If you want to install it on your computers and you have problems, you're free to write me an email. Yes. So let's all try to launch it first. So the way we will do this exercise is I will give you some small tasks. You will perform them. We will make sure that everyone is following. And then I will give you more tasks, and then you will implement them as well. So for the moment, please do the following. I show it on my computer. So you need to open Anaconda PowerShell. This is basically a tool that works with Conda environments. And it looks like this. And what you need to do here is you need to type Conda activate AB. AB is the name of the environment that we have created for you. Once you've done that, you can see that here you see the words AB appear. That means that you activated the right virtual environment. And to start the Activity Browser, you simply need to type Activity Browser like this. So once you've done this, you should see this welcome window. You do have slides for this of this presentation on Moodle, by the way, in case you need to see the steps. Let's try to create our first project in the Activity Browser. But before we do that, let's have a bit of a recap about lifecycle inventories. So basically, the building blocks of the lifecycle inventories are individual processes of human activities and their exchanges with the environment and with other human activities. The exchanges can be of two types. It's the elementary exchanges, or in other words, biosphere exchanges, so the exchanges with the environment, and the intermediate exchanges with the technosphere, so with other, or in other way called technosphere exchanges, with other human-made activities. Lifecycle impact assessment Lifecycle impact assessment methods are used to quantify how much damage or benefit is associated with an elementary flow or elementary exchange in the form of so-called characterization factors. So if you look, for example, at the climate change impact category, global warming potential in the time horizon of 100 years, then we can see that this impact assessment category is quantified in kilograms of CO2 equivalent. And so for all of the carbon dioxide flows, it would have a characterization factor of 1. Whereas for other flows, such as, for example, methane, the impact assessment would say that the effect of methane is 20 times higher than the effect of the carbon dioxide, and that's why its characterization factor is 29. So impact assessment methods would basically collect elementary flows and assign some kind of a number that weighs it such that all the flows are in some way unified, or their impacts are in some way unified. If you look at the complete lifecycle assessment, after you've done goal and scope definition, then you would have your processes here or activities. Don't yet look too much at the markets. We'll discuss them a bit later. But basically, you have your activities, and to generate value chains and compute environmental impacts, you need to collect these individual activities in the supply chains, or also called systems, where natural resource consumption will occur at different points in the supply chain. And in the end, you kind of accumulate all of them, and we have a list of the elementary exchanges with all of their values. So how much emissions are caused in the supply chain. And this is called cumulative life cycle inventory. But the inventory by itself does not give you yet impact assessment score. To convert it to the impact assessment score, you need to multiply each elementary exchange by its characterization factor. So in this example, if we have 1 kilogram of methane and 5 kilograms of CO2, then 1 kilogram of methane will be multiplied by 29 because the characterization factor is 29, plus 5 kilograms of CO2 will be multiplied by 1, the characterization factor of CO2. And overall, the impact score would be 34 kilograms of CO2 equivalent. So in the activity browser, we create projects where each project is a separate life cycle assessment case study. And the different projects, they contain databases, methods, databases contain activities and exchanges, and the different projects are independent of each other. So for each lifecycle assessment case study, you would have a different project. The examples of databases can be foreground databases where you collect the data yourself, which is what we would essentially be doing today on a case study, or background data, such as, for example, Ecoinvent Technosphere. Then we have databases can also be here, Biosphere and Technosphere. And overall, the examples of the databases are, for example, Ecoinvent or Exibase, AgriBalise, AgriFootprint. Maybe you've heard of some of them. Each database contains activities. Activities can be biosphere and technosphere activities. Biosphere activities, for example, methanol emission to air, whereas technosphere activity could be methanol production. The exchanges are basically activities with amounts. So, for example, to produce 1 kilogram of methanol, we would need some amount of heat, some amount of electricity, some amount of water, and so on. And during this process, we emit methane, nitrogen oxides, and all of these are different types of exchanges. Like on top are the technosphere exchanges, on the bottom are the biosphere exchanges. Now, the impact assessment methods or categories could be climate change, global warming, potential over 100 years, or freshwater ecotoxicity, or particulate matter formation, and so on. So let's create our first project in the activity browser. For that, you need to press New in the activity browser and name your project in some way. So always when we start, what we do first is we import we add biosphere activities and impact assessment methods. So this is basically here, this button, add default data, and it's biosphere and LCA methods. So just go ahead, press it. It will take, I don't know, maybe 5 minutes or a couple of minutes to compute. And meantime, let me explain to you what you can see in the biosphere. So once I have imported Biosphere, basically what I can see is that this database appears in the list of databases. And if I double click on it, then I can see all of the different activities or like emissions that are present in this database. So you can search for specific ones and you can explore their properties, or you can see if it's emission to air or water. All of this would be in this table, also the units. At the same time, if you switch the tab there on the top to the impact categories, then there you would be able to see all kinds of impact categories available to you by default from just the imported ones, where we press this button at default impact categories. Basically, if you double click on one of the impact categories, then what you would see there, and if you choose the tab characterization factors, then you would see what are the different biosphere activities and what are their amount. So the amount is the characterization factor. Okay, it seems like it's working for some of you. For the ones for whom it's not working, just keep waiting. At some point it's gonna work. It just takes a bit of time. Now, we imported Biosphere, so we have Biosphere activities. The next step is to start working with the Technosphere, and the most commonly used Technosphere database is Ecoinvent Database. You should have heard about that during your lectures, but let's recap a little bit. So Ecoinvent is a background database. It is updated yearly, and the most current version at the moment is 3.10. In this course, we're going to be using 3.9.1 though. Ecoinvent contains more than 20,000 life cycle inventories and more than 3,000 distinct products. It covers supply chain of or goods and services across all kinds of industrial sectors, including agriculture, buildings, chemicals, energy, forestry, metals, textiles, transport, waste treatments, water supply, and so on. So it's quite a comprehensive database. And the import of Ecoinvent takes a bit of time as well, 5 to 10 minutes maybe. So let's start importing now. Just follow these steps again. Press the button import, then import remote data. Choose the Ecoinvent, the right version, choose the cutoff version. And when you need to add the credentials, just copy paste this password. And if it doesn't work, then maybe there's a space in the end. So you need to delete maybe one. Okay, if the import is again, if you see that it's somehow stuck, you can try pressing enter again a couple of times in the PowerShell. That's like not religiously, just a few times. Okay, and I think everyone has started doing. Okay, while we are waiting for Ecoinvent, let's discuss the Eco query. I think you also had it during your lectures, but basically what you can also do is you can go directly to the Ecoinvent website, to their special tool called Eco query, where you can search the database. So just follow this link. It should already lead you to the right version. So 3.9.1 cutoff version. And if you log in with the same password that we have given you, then you should be able to see those different data sets. And what you can do is you can start exploring them. So if you press on the details, then you will see all kinds of information about these data sets. So let's do it together. For example, if you look at the methanol production, then usually if you're modeling your foreground system, for example, and you need to link it to some background process, then you would probably start by reading whether this process is exactly what you need. So the information is basically here. You just need to read and understand how this process works, what exactly it represents, and then you decide whether it works for you. Here you can see all of the exchanges that you can see, like intermediate exchanges on the left, elementary exchanges on the right, so both technosphere, biosphere exchanges directly in this tool. And what you can also see is what are the consuming activities. So what kind of activities take the methanol production activity as an input. Then you have LCI results. So your inventories already collected in this tool. You can also take a look at them. And you see also some impact assessment results already. And you can change some of the methods here. So in Ecoinvent, there are unit processes that represent your activities with exchanges, and these unit processes are gate-to-gate inventories. So it's basically what we discussed before. It's activity and plus its exchanges. The methanol production would be a unit process. Now, often in Ecoinvent, the data is reported on the national level, which means that Ecoinvent provides values for like averages collected from different producers for a particular technology for the whole country. So this gives you kind of the background data. And unit processes are unlinked. So there are no suppliers yet, and they also have multiple products. Yeah. So these are at the moment multi-output activities. To generate value chains and to actually calculate environmental impacts, you need to collect these different individual activities or unit processes into supply chains. You need to link them all together. And these form together system processes. And the supply chain is determined or linked. And by using this special rules, you produce single product unit processes. And the special rules are determined by the system models. So Ecoinvent has a number of system models. basically a system model sets the rules to calculate life cycle inventories of products and services. It applies different assumptions on how to link the processes in the supply chain and how the impact should be allocated to producers or to consumers. There are different types of system models. So there are allocation system models. These are basically the methods applied in the attributional approach to convert multi-output activities into single output activities. And there are also substitution methods that follow the consequential approach. So you will learn more about this during your master studies. And for now, we are using allocation cutoff by classification. And in Ecoinvent, when you were importing Ecoinvent, you must have seen that you can choose you can choose from a list any one of them, any one of these system models. So hopefully all of you have chosen cutoff by classification. Now there are also different types of activities that are present in Ecoinvent. Most of the activities are really just ordinary transforming activities. So it's basically everything except for markets. Activities that transform input in some way to an output. For example, the activity methanol production, coal gasification would produce methanol from coal. Market activities, on the other hand, they create consumption mixes. So they collect a number of different activities. For example, hard code the supplier to hard code the consumer. And the suppliers can be from, I don't know, for instance, different countries, and their mix will be created by taking the respective shares of those suppliers and making them into one consumption mix. So these are markets. They account for transport and losses of the product as well. Now, when the Ecoinvent import is done, what you can do is you can also explore Ecoinvent in the same way as you've looked at Biosphere activities before. So you just need to double click on the Ecoinvent database. It will give you the list of all kinds of activities, and you can here filter them, find activities by name, for example. And here you can also look at what is inside each one of your activities. So it's basically the same information as you have in EcoQuery, but now it's also in the activity browser. What you can see here in the activity details, for example, is that first of all, you will get a detailed description only if you tick the description mark over there. Also, if you want to see Technosphere, Biosphere activities and the consumers, then you also need to tick, and then you will see all of them. What is also important to note here is that there are different so-called geographies in Ecoinvent. So each activity provides some kind of a production average for a specific geometry. So for example, here in the location, you can see a number of abbreviations. Some of them are, for example, global averages. So it's for the whole world. If you don't have any country-specific data, then you can just use a global activity or global data set. Some of them are ROW, so these are rest of the world. That means that for an activity with a specific name, if you have a number of such activities and some of them for methanol production, for example, if you have this activity available for a number of countries, but not for all of the countries in the world, then you would probably see, in addition to country-specific data sets, you would also see one data set that is ROW, so rest of the world data set. And this is basically all of the countries minus all of the countries for which this data set is available. So it's basically world minus what is already there. Kind of an average for everything for which you don't have country-specific data sets. Now, other locations relevant for us, especially in today's case study, are maybe CH is the Swiss averages, RER is the Europe, including Switzerland. There's also a data set Europe. There's also location Europe without Switzerland. And just for your information, some countries also have specific regions, like US, China, they are even more granular. If you want to delete a database, you can just right-click and delete. Please don't delete Biosphere or Ecoinvent. as it probably is taking us some time now to import them. But in general, you can delete a database, of course. You can also delete the whole project, as shown here. But please also don't delete the current project. Okay, now let's see if everyone, we quickly check now if everyone has imported Ecoinvent and Biosphere, and then we can move to the case study. Okay, it seems like Ecoinvent will soon be imported for everyone. And I think then we can move forward. So what we have prepared for today is the case study on plastic food container. The goal of this study would be to conduct life cycle assessment of reusable plastic food container. And you would need to identify environmental hotspots and see where you can improve environmentally. The functional unit here is one reusable food container. The assumed volume is 1.1 liter, and the number of uses during its complete lifetime is around 400. So you wash it 400 times. Scope is cradle to grave. And the overall kind of a supply chain looks like this, where you have the three different components in your food container. It's the lid, the silicone seal, and the container base. These are transported to manufacture a food container itself, which are then packaged and transported to the user, and then afterwards to a waste incineration facility or so. So, but here in this case study, at the moment, we will exclude the use phase. This is something that you will do afterwards on your own. For now, we will exclude it. So the system boundaries are as follows. For the extraction of raw materials and production of the different components of the food container, you have polypropylene for the plastic container itself and its lid. You have silicone for the lid seal, and you have cardboard for packaging. For the production, there are some extrusion and thermoforming of the polypropylene activities and silicone, and you also need to produce the packaging. For the end of life, we will dispose of all of the waste generated through the life cycle of the food container. Now, for the transport, we account for the distribution of raw materials to the manufacturing side, then the distribution of the food for the manufactured food containers to the retailer, and transport of the after the use phase. Geography is Switzerland, so we are modeling everything for Switzerland, and if this datasets for Switzerland do not exist in Ecoinvent, then use the European datasets. It's the RER geography. Now let's model the materials. So you can see here how you can do it. You first need to create your own database. You have now created Biosphere, you created Ecoinvent, and now you're creating your own foreground database. You can call it food container LCA, for example. This is the step 1. At the step 2, you need to add a new activity, which is, for example, a container lid. And you need to add all of the exchanges that pertain to this activity. So a container lid would have an exchange of polypropylene. You would need to find it in Ecoinvent, see which one is fitting, read the description, or read about the dataset in EcoQuery, and decide which one fits you. You can you would need to create a new activity. So you create the activity container lid, for example, and then in this activity over here, you would need to modify units, locations. So units we give here to you, they should be kilograms, locations should be Switzerland. And yeah, when you add Technosphere exchanges, make sure that the flows option is on. And what else? Yeah, and then you can just from Ecoinvent, you can search for a particular market, for example, and just drag and drop it into the Technosphere exchanges. And you need to do it for all of the parts of the food container. So it's the container lid, it's the silicone seal, it's the plastic container base, and it's the packaging material as well. After you've modeled that, you need to model the overall production of the food container. So now we show you what, like 1 kilogram of this food container, how much what are the amounts of the container lid, seal, container base, and packaging material in the 1 kilogram of the food container, and what are the electricity and heat needed to manufacture it. After that, you would have to model the whole life cycle. So you would have to add, so you would have to keep in mind that the one container weighs 210 grams, and you would have to model the transport as well. We say here that the distance, the overall total distance is 100 kilometers, and we assume that that your transport is loaded 100% one way and is empty on return. And the transport has units of ton kilometer, which means that you would need to also convert the units correctly. So take a look at the transport data set, see exactly what it needs, and calculate the amount of this exchange. And also afterwards add disposal to incineration scenario for Switzerland. Yes, I think we can, yeah, go ahead and model your foreground, and afterwards we can compute life cycle impact assessment scores together. Okay, so basically we have our plastic container, its complete life cycle. What we need to do next is we need to actually compute impact assessment score. And how you do it is you create a calculation setup. So new calculation setup, and you call it somehow. I called it first LCA. And then it shows you two boxes, basically reference flows and impact categories. And into this boxes, you can simply drag and drop your activity. So I already have done it. And then you also choose an impact category from the list, and you can drag and drop it into impact categories as well. Once you've done it, when you press calculate, then you will see your impact assessment score in some time. Yeah, here. So for me, it's 0.5 something kilograms of CO2 equivalent. Next, what I also wanted to show you is that you can always, in Activity Browser, take a look at the contributions from the different elementary flows. So is it the methane that's contributing the most? Is it the CO2? Basically, here you can take a look at the contributions. You can either have, I explained in the slides a bit more, but basically here you can have some kind of a cutoff level. So you don't want probably to include all kinds of flows. You only want to include the ones that are above some threshold. And this threshold can be determined here, but by this cutoff level. It's basically a percentage of the total impact score. So you can change it a little bit and see how your diagram here changes as well. Or you can say, I want the top 10 flows that are contributing, and then your diagram would again change, and here you would also see a table. Yeah. Same goes for the process contributions. Here as well, you have the same cutoff level, you have the top contributing flows, so you can also choose to which extent you want to see which processes contribute to your total impact assessment score. Now, if you move to the Sankey diagram, I guess this one is the more interesting one, because, and here you might need to do like refresh HTML so that it's more full screen. But essentially what you would see here is you can see contribution analysis with the Sankey diagram. So we start with the plastic food container, and we can see how much is the treatment of waste, or how much is the container production, where the impacts are coming from. And you can follow it, and you can see that the impacts from are mostly coming from producing the container lid and the plastic container base. And both of these are coming from the polypropylene production. So you can kind of see the tree, and you can analyze a bit where your impacts are coming from. Yes. Maybe one more thing that I wanted to show is, in case you want to, in your setup, have multiple impact categories, and you want to have multiple reference flows, then you can simply drag and drop all of the impact categories here. And you can also have multiple activities in here. And then you can also calculate your impact scores for many things at once. And you can either choose here by impact category. So for each impact category, you can see how your impact scores look, or you can have a complete overview of everything in the same time, as it is here. And of course, these tables and plots that you generate in Activity Browser, you can also export here below. Okay. Yeah, try doing that. And does anyone have any questions? Yeah.
But how are we supposed to know like which heat to use?
Yeah, so which electricity or which heat to use is basically your modeling choice. If you are modeling a specific food container and you know a specific producer and you know that you can get the data from them, then you go to them and they tell you what are they using. If you want to know, if you're modeling some average one, then you need to make an educated guess. So it's really a matter of reading the data sets in EcoQuery or in the description of the data set and understanding which one fits you the best.
In the exercise, you would like heat to heat the or heat to thermoform?
Yes, it's heat for producing, yeah, for thermoforming, yeah. And you can always do a simple sensitivity analysis. There's also a slide on sensitivity analysis in the very end, basically here, where you can always estimate what is the impact of your choices, basically. Like, for example, when you're creating your foreground inventories, the amounts in those foreground inventories, they can come from measurements, or there can be assumptions made on the electricity mix, for example. So what you can do is, of course, these are, yeah, the measurements can contain uncertainty, or the assumptions are basically your modeling choices and somebody else might do it differently. So what you can do is you can run sensitivity analysis. The easiest form of sensitivity analysis would be, you would try to answer the question, how much does my modeling choice affect impact assessment scores? Because maybe no matter which electricity you choose, it doesn't actually affect the results so much. Or maybe if your container weighs plus minus 20% of the weight that you chose, maybe it's also not such an important parameter. So what you can do is you can simply in your foreground inventories try to change these values and see what is the impact that they have on the impact assessment score, or what is the effect they have on the impact assessment score. And if you see if some modeling choice is very, very important, then probably this is where you should focus. This is where you should know better. So you should, I don't know, research more or ask people who are at who are producing food containers and so on. Okay, I think we have a couple of more minutes to quickly introduce the exercise, the graded exercise that you would have to do. This one is very similar, and it's glass food container and the comparative LCA that you would have to perform. So you would have a couple of tasks. One is, so goal and scope. Here we also specify specific, like in detail, what is the goal and scope also for the glass container. And now in this case, at the beginning, we also exclude the use phase. For the task one, we exclude the use phase. Now here, the packaging material for the glass container, so some of the materials are different. Obviously now for the container base, you would need glass. And for the packaging materials, you would need some extra bubble wrap because it's glass. For modeling the food container, yeah, it's more or less the same with different numbers. And you would also need to model the complete life cycle. And at the disposal, you would need to separate between glass and all of the other materials. And then you would have to answer the questions. You would have to compute impact assessment score for the global warming potential, 100 years, climate impact category. And you would have to say which of the environmental flows contribute the most. So which are the top 3 and which processes are the top 3 for the production of the glass container. And you would have to compare the scores between the plastic and glass and see which one is bigger and why. So maybe study a bit the Sankey diagram. Yeah. For the task 2, now we would also model the use phase. So we would assume that the total number of washes is 400, and that sometimes people, in 50% of the cases, people wash their containers manually with hands, and in 50% of the cases, it's in a dishwasher. So we provide you some inventories here for both. So for washing the container 50 times in a dishwasher and for washing the container 50 times manually, we provide different inventories that you would need to add to your foreground database. And afterwards, you would also need to compute impact assessment for three impact categories, namely climate change, ecotoxicity, freshwater, and water use, and compare them, or see which for which container, type of container at which no, it's only glass here. See for which impact categories, which life cycle stages are more important, for example. Basically answer some questions here. And then a very, very simple kind of like a sensitivity analysis here in the end would be to decrease the number of uses to 200 and see how this modeling choice affects the results as well. Are there any questions? Yeah, all of the project will be saved. If you just close it, then next time you open it, it will work again. And you can also open it in a different computer and it should be still saved. And if it's not, then write me an email. So you can just close, and next time when you want to work with it again, you do again Conda activate AB activity browser, and you should see your projects. Okay. Then I think with this, the exercise is officially over. Yeah, if you have any questions, feel free to write us an email.